Yes, welcome to this session. I hope I'm in the right room. This is 42 silly ways to say hello in C. And despite the title, it is actually a serious attempt to talk about important stuff in the C programming language. But I use silliness as an excuse for not necessarily building up all the arguments correctly all the time. So let's start where every tutorial, everything about C should start. And that is with a proper hello. And this, you might think about this as kind of the correct scholastic example that should be used. We are checking the return values. We are indicating to the runtime environment whether it's a failure or a success. And it says hello, of course. So that's the first hello. Actually, I've lost a bit count on how many hellos there are, so maybe it's not exactly 42. When I showed this example to someone at this conference, said, "Oh no, you're showing without braces." And I don't use braces. Koenig and Richard don't use braces on single statements like this. Of course it works, but what you're indicating here is actually a compound statement. It is okay, I accept it, I would do that if the rest of the code base is like that, but I don't accept the argument that it's wrong not to use those braces, because this is now introducing a compound statement with one statement inside. Actually, if you like braces, why not add a few more? This also works. So if that's your cup of tea, if a few set of braces is good, then more of them must be even better. Another argument that came up was, oh, you're using puts. I accept that one. And it's quite common to see printf used instead of puts. Then you get kind of the luxury of adding the new line yourself if you want. So that's okay. So this is also a good hello. I take that one. However, trying to be correct about everything is a bit difficult. And in this case, we are not just indicating success or error by a kind of silent 0 or 1. We are basically shouting it. Exit, failure, exit, success. And therefore, you feel that you have to report things correctly, and you have to do things properly. And when you use printf, printf has a slightly different way of returning errors. So it will either return end of file or the number of characters printed out. So this would be the proper way of checking printf. And if you typically, when you look at, well, if you see the discussions around these things, there is some kind of consensus that it is okay not to check stood error and stood out on most systems. So that's what I'm going to do here as well. I'm not going to check error on stood out, and then maybe we can discuss that later, but for now, okay, it works. But for now, I'm just doing it like this. Actually, I'm going to slim it down even more, because this one is shouting success without me actually not knowing whether it's success or not. So I like the slightly more kind of subtle 0, which is the same thing, of course. And even since I have been doing a lot of C++, and in C++, it's very, very common to do this. It's not an error. And C99 followed, so they defined in the standard that implicitly dropping out of main is okay, and you will be guaranteed 0 as the return status. That says in C99, and that's just 23 years ago. So And of course it works and doesn't give any warnings or errors. Yeah, so here's what happens on an Intel CPU. It just resets the return value. But also notice here now, it's calling puts, not printf. This is important thing to know about C, also C++, of course. And that is a language defined by behavior, not by implementation. So if you are not supposed to know the difference between puts or printf, and in this case we don't take the return value anyway, the compiler is free to say, I probably wanted to use puts, so I just flip puts and use puts instead. And this is something that's useful to know if you put on your debugger, because it might not run the code as you think it runs the code. And this is what we get when we have a language defined by behavior instead of by implementation. By the way, this is just an example. This happens absolutely all the time. That the assembler and the code produced is different from what you think it might be, as long as the compiler knows, according to the standard, that you are not supposed to know the difference. Now to something completely different. Right, series of putchars. Putchar and a lot of the library functions in C take integers and return integers. It's mostly, historically, it was mostly so they were able to report -1 or end of file. But there are probably other reasons as well. And these days, with large character sets, there is another set of library functions, input-output, that is in the C standard. I will not cover that, but for this talk about silly ways of saying hello, I start out like this, and it's getting worse. Please, hello. This invites to create an array of integers with these values, and where we use an integer to index into that array step by step until the very end. But I hope you attended the talk yesterday with Robert Secord, or today, because he's talking about something very important. And I belong to his school of thought. I am very consistent on you shall use at least not integer to index into arrays. It creates a lot of problems, and it also is not very portable. The portable way of doing it is to use size t. And you don't know what size t is, except that it is an unsigned large integer that can address enough memory. It's usually an unsigned long on a lot of machines, including mine. All right, one gives hello. Notice I didn't claim hello for the int version, so I have some decency. All right, let's optimize this one. Yeah. We do have gotos in C, and I'm not encouraging people to use gotos, but I think it is problematic if you, as a C programmer, are not able to read code written with gotos, and if you are not able to get beyond the point of just seeing the gotos and nothing else. There are files in the Linux kernel that has, I think, up to 70 gotos in the same function. And a lot of the gotos used correctly around actually improves the code, not destroys the code. So this idea that goto is always bad, I don't subscribe to that anymore. I don't use gotos except from educational purposes. But there are situations where it is better to use goto than going all the way to go around the problem. It's especially when it comes to cleaning up resources, for example. But in this case, there is no good reason. So I'm going to refactor it. But the reason why I start here is that I would like to show what it means to be a high-level language. Well, high-level language, like C. Because there is a translation that is going on now from using goto through do while to while to for. And that's the one I'm going to demonstrate. But I'm going to claim hello for that one. C doesn't care about indentation and those kind of things. So indenting this thing in and putting these on the same line, I do that only because of the next step. Because then I can look at those two things. And this is more or less exactly what it would look like in assembler. Assembler doesn't have this construct, do while. So that's the first step into being slightly above assembler language. Yeah, I can remember for that one. But there are situations where do while is the best approach. Oh, I wish I had the cartoon I got the other day. I do have it, but I'm not going to show it here now. Maybe later. But there is this thing about actually doing something before checking the invariant. Sometimes it's the right thing to do, but very often you should feel encouraged to check the invariant before you go into the loop. It makes the code easier to reason about, and that is what you have the while loop for. So, and in this case, it makes absolutely no difference. Well, in what we are trying to do here. So by swapping these two, like this, we have the while loop. Now we are looking at the situation, well, hello, yes. We are looking at the situation that is very, very, very common when you are using while loops. You have first a declaration with an initialization, then you check the loop invariant, and then you do an update of the variable that you're using to loop with. And this pattern is so common and so useful that a lot of programming languages, including C, has a particular keyword and mechanism for looping through those kind of things. And what you're looking at now, and I'm going to transfer it into a for loop, is exactly the same as you see in the for loop. I believe you get exactly the same machine code when you compile this example and the next thing I'm going to show you. So let's look at that transformation. So take this one. The for loop has 3 spots where you can put these things in. So here I'm only using one of them. So that's where it goes. That's the condition, loop condition, the invariant. And then we can take the declaration and the initialization, and we can stuff it in there. And we can take this one and stuff it in there. Now, if you are able to do this translation quickly in your head when you look at for loops, then you will be never confused about when is this one updated, because it is at the end of this compound statement. However, if you are not used to that, then it might be a bit confusing. So my recommendation is try to avoid using the for loop unless you use it for the typical scenario. This kind of scenario. It's fairly simple stuff. As soon as you start doing advanced things with for loop, you probably want to use maybe a while loop instead, just to indicate, be more explicit about what is happening. And I think this is particularly important in C++ because there is so much magic happening in C++ when you, for example, update variables or objects, and also when you do things in this iteration. All right. So now I've simplified this thing, and that gives me the pleasure of and it says hello. This is a pre-increment. In this a lot of C programmers, they seldom use pre-increments unless they have to. There is this tendency to use post-increment instead. I don't actually understand why, but I just accept that that's so common that when I program in C, I often use post-increment. When I program in C++, I always use pre-increment. And I consider myself bilingual, so I can switch between those languages. I don't have to kind of do C when I program C++. I don't have to do C++ when I program C. So I don't mind swapping those around. And in C, it's never really a problem, at least not in this case, to do a post-increment instead. I'm not encouraging post-increment though, so if you come to a code base that is basically using pre-increment, yeah, go for it. Because it feels slightly better to do. But if you come to a code base and all the others are using post-increment, don't be kind of this strange person that kind of introduces this pre-increment everywhere and are not able to do anything value-adding services for the group. Hello. I have a line here. I need to fill it with something. There it is. This is an idiom. I like idioms. C has plenty of idioms. And I think you should get used to just read that one. Size of something divided, well, size of an array divided by size of the first element. And that gives you the count of element in any kind of array. And it is so common, so useful, that you will find it all over the place. And basically what it's doing, it's enables you to remove this one. And that is a language feature. Because the compiler will realize, well, there are 6 elements, I will give you 6 elements. And then you can calculate how many elements there are. Blue. Oh, before I move on, I need to do some fun with this one. But also because I need to build up kind of insight before I show something else afterwards. What you're looking at there, the square brackets, they are actually an operator in C and C++. That you can, that has an equivalent. It's just a syntactical nice way of saying this. It's the same thing. It even says in the standard, I think it's used as one of the examples in the standards. It's definitely one of the examples in Kernel-Ritchie, that they are the same thing. Now, plus, you can swap them. Let's do that. And then go back to the square bracket thingy. And you can do this. And it doesn't have to, I doesn't have to be an object or a variable or a symbol. It can be a literal. So if you want to go to the third element into an array, you can do 2 square brackets A, for example, in this case. And it says hello. It works. Yes, it works. I've seen this this use a few times in real code, but most of the time, well, in kind of production code and so on. But most of the times when I see it, it is to trigger a compilation error. So this is one of the plenty countoffs that you typically, if you look up on Stack Overflow and I need a countoff macro. Eventually someone says this is one to use or something like that. And it's clever. it gives you a compilation error. Actually, I haven't studied it that deep, so maybe what I'm saying now is not completely correct, but it gives you a compilation error if it's not the type of array you hope that it should be. I just realized I haven't studied it enough to talk much about it, but it is an example of using this one. In real life, I have seen in the large code base, working with the audio-video processing, I saw this use for picking up out particular audio codec. And when I looked at it, I thought, it actually looks quite nice. It's strange, but it looks nice. And it was an appropriate place to do it. It was kind of geeky, but it was, yeah, it gave me a fuzzy feeling of it. Cool. I think I've also found it a few places in a Linux kernel, and with acceptable reasons for swapping those two. Anyway, we are moving back, so I'm done with it for now. This, now that we are calculating the number of elements, by the way, I wouldn't suggest replacing this idiom with a macro. There are plenty of idioms in C, and also C++, of course, in any language, but also in C, that replacing it with a macro doesn't add anything. You just save a few, and I think it just makes it a bit harder to read. So idioms like this, I think you should just accept them as they are. But this one is quite nice, because that also means you can change the number of elements, of course, but you can also change the type, and it would just work. So going from int to short, on some machines that's the same size, but on my machine it's different size. And I don't need to care, because this calculation takes care of that. All right, I need a hello for that. And then I go further with this one. Now we come to another learning moment. It is common, well, we have kind of the signed integers, unsigned integers. We have signed long, unsigned long. We have signed short, unsigned short. There is common to think that there are just two char types. There isn't, there are three. You have unsigned char, you have signed char, and you have char. And this is actually quite important, because char is kind of different from anything else. Char is implementation defined, if it's signed or not. You can switch it during compilation time, for example, and you often shouldn't care whether char is signed or unsigned. If you need to care whether it's signed or unsigned, you need to be explicit about it. And the rule of thumb is that if you are really wanting an 8-bit integer, you should use signed 8-bit integer. You should use signed char, and if you want an unsigned 8-bit integer, you should use an unsigned char. If you are dealing with letters, characters, the alphabet, and so on, ASCII, then or ASCII, then char is the one to use. Hello. Making some space, because what I'm going to do now is to extract the function myPutChars. It looks like I have created a function that takes a character array, and then I find the size of that one and I print that. But that isn't what happens here. This might give you hell. Typically on a 32-bit architecture, you would get hell. But on a 64-bit architecture, it might get much worse. Because now you're stepping into undefined behavior. And on undefined behavior, anything can happen. Kind of the universe and the rules of the universe just breaks down. Attempts to reason about undefined behavior is usually futile and not very healthy. But at the same time, it is interesting to see what computers do, though. So I tend to live slightly outside of defined behavior when preparing for talks and other things, and then I try to stay slightly on the inside when I do real work. But yes, that could certainly happen, the thing that you see on the bottom there. Oops. The problem, I think, is this one, and it's kind of a syntactical thing that is deceiving you and us, because there is no way to transfer arrays like this in C. So it looks like it's an array, but it is actually a pointer that you're getting. And that is the reason why I recommend always, and I try to be good myself, to always do this and not try to use these square brackets as some kind of lame documentation. Be honest about what it is, then it's probably much easier to see that this doesn't work at all. So with that insight, you probably understand that you need to put this calculation on the outside, and then you need to pass this as an argument to the function. And this is an acceptable way of doing it. Now we have using a pattern of passing the base pointer, and then we pass the length of that array. That gives me a hello, and I think this is a decent piece of code. There was yesterday an argument about this one, and I have followed that argument about this one for at least 15 years. It's not very common in C, generally, code bases in C to use unequal in this case. It's perfectly okay, of course. It gives the right result, of course. But there is something in the traditional C that it's less than. And at one point, this must have been 10 years ago, so it probably changed since then. Someone pointed out to me that, well, compilers, when they're compiling code, they typically look for patterns that they can optimize. And he made me aware that one compiler he was working with didn't recognize this loop, while if you had less than, it optimized the loop. So he won the argument. I lost. However, if you are into C++, then this is the way to, often the way to end an iteration for many good reasons. So you can see, often you can see whether people come from a C++ background into the code base or from a C background into the code base. But I will leave it there for a while, because I'm going to be more inspired by C++. Funny fact, actually. I have been doing both C++ and C for many, many years. And for some reason, whenever I give a talk about C, people assume that I hate C++. And when I do talk about C++, people assume that I hate C. And I find that fascinating. I do other programming languages as well. I also teach Python, for example. And they think I hate C and C++. But I think I'm more like people working in the kindergarten, the teachers. I love every kid. They are just different. I also love C, but I like to do C in the C way when I do C, and I do C++ when I do C++, and so on. But sometimes I allow myself to be inspired, and I try out IDs from C++ also in C. And so, yeah, maybe I switch that one back to prepare for the next step I'm going to do, which is to calculate the beginning and the end of this array. And then change the loop so that instead of indexing into an array, I start with a pointer to the beginning and I iterate till it points to the end. And note that is one past the array. And then I dereference the iterator and I use putchar. Now this one past the array is a very important thing also in C, and of course in C++. You shall be able to calculate one address past any array. It says in the standard, and that also means, for example, the compiler is not allowed, probably not allowed, to put an object in the very far end of the memory so that you would get a wrapping or an overflow, because pointers overflow, by the way, they don't wrap, pointers overflow. So that if you calculate the address, they have to leave one computed, addressable element behind. However, of course, you can't dereference it. So, but this pattern of finding the beginning and end, and the end is one beyond, is very common in C++. And yeah, you can use it also in C. And in this case, we realized that maybe we should, instead of doing the work of sending the base and the length, maybe we should just put them into like this. Putchars from beginning to end. And while I'm on the track of being inspired by C++, let's see if we can do have some fun with this one. Instead of my putchars, maybe I can do my for each. So that I send in the beginning and the end, and I also send in a pointer to function. And do, for each element, apply this unary int function. What I send in is putchar. Now, you need to be a bit careful about sending in this, taking the address of functions, especially library functions. And I didn't have time to actually go in and check the wording, so it's just from my memory. But I think the wording is around that it is acceptable for the compiler to use, well, of course they don't mention macros, but that you should be careful about taking pointers. Is anyone that remember that phrase in their head? Okay. For example, the is alpha, is white space, if function, these kind of, they are very often macros. So if you try to send them in like this, I'm not sure what the compiler will do. They will probably find that you're trying to do the address for it and then figure out how to compensate for it. But at least you should be a bit careful about this. But it worked here. It works for me. So I've taken hello for that one. Let's rewind. Well, that's an undo symbol, isn't it? Undo this one, because I will do another attempt of going in the C++ direction, and then I will give an argument for why you shouldn't do that. Let's rewind. This is back to the code that we had. Now, there is another way, and here we have a base and the length. There is another way we can communicate well, we can send over a pointer and work with it without knowing exactly how big it is. And that is if we do a convention of adding 0 in the end of this particular array. And then check, our iterator can then check for that 0 so that it knows when to stop iterating. And when we do that, we don't need the end anymore here. We don't need to do the size calculations as we have done. We don't need to pass the length into the function. So we can get rid of that. And it says hello. Surprise, surprise. And of course, this one is a bit too much because that's exactly what it would say if you just do dereference it as well. So you don't need to say unequal 0. It depends who you are communicating with, but if you are communicating with compilers and other programmers, you probably don't want to do that. So this is an exact way of communicating and a very acceptable way of doing it, I think. But when we are shortening things like this, maybe we should shorten it even more. This is also an idiom. This is how code looks like if you read Koenig and Ritchie. This is how code looks like if you read C code written by experienced people. It should just be something that we should be able to read and appreciate as it is, instead of wishing that it was different. So yeah, I leave it like that. I also need the screen space and so on for the rest of the exercises. So you will see a lot of putchar. I will not change that one much for the next few hellos. But I claim hello for that one. Oh, it's time to reveal. What are these magic numbers? What could it be? Well, they are, of course, ASCII representations of these same letters. So what you're looking at here are integers, integer literals. These are character literals. That is now initializing this array for us. Used to initialize this array for us. And this, what you see here, is exactly what you get if you do this. Now, maybe unknown facts, or not so common knowledge, is that C doesn't support a string type at all. C has arrays, C has characters, it has some support around literals, and a few extra things, but it doesn't have a string type. And people are often dreaming about string types, and my guess, it will never happen. But I've been wrong before. But I don't think we will have a string type ever in C. You might build it yourself though, but I don't think we will have one in the standard. It says hello. But important to know now is that the size of A has changed. Well, it looks like it might be just 6 characters here, but there is a 7th character implicitly. So when you create an array out of this, then you might be surprised that it's now 7. Well, you shouldn't be, but maybe you get caught once in a while to calculate it wrong. Size of is not really good for calculating, working on strings anyway. Oh, by the way, gave me a chance to show the ZU. That is the portable way of printing out size T. So if until, actually I don't remember which standard, but before a certain standard it was really difficult to use printf and size T, for example, because when you compile it on a 32-bit machine it was typically different from a 64-bit machine, and but we now have a portable way of printing out a size T unsigned integer. By the way, here's another kind of discussion that sometimes happens. And it's this one. Shall we have braces? Braces is better. No. This is the keyword size of the keyword operator. No, sorry, the size of operator. And it has this nice feature that it can only work on objects. It cannot work on types. So if you want to know the size of a type, you have to put the braces in. But if you take size of an object, you don't need the braces. And you shouldn't like braces. So therefore prefer to take size of objects instead of size of types. It usually makes it a more better program. If the objects change, then size of calculates correctly. If the object change, then if you have specified size of int, then it will still be size of int, for example. Then they might argue, oh, but I want braces anyway. Yeah, you can have as many as you want, I say. That works also. All right, let's clean up the code and go to something completely different. It was difficult to make the transitions perfect here, so I'm just showing the code and then I switch over to something else. But what I'm trying to do here is to create a situation where we have some noise in the string, dots. And I have written a small remove dots, I hope it's bug-free, that is basically going through this string, and every time it is not a dot, then it's copying it into itself, while the sentinel is always moving forward, searching for new things that are not dots. And eventually we zero terminate the string that we are given. And that works. This is a good time to talk about Const. If you are in a code base that do this, in my opinion, correctly, and always and consistently, then when you see a function that takes a const pointer, then it's not intended to kind of change it in any way. It's just going to refer to and read it, obviously. But and that's obvious, of course, since it's a const. But that also means whenever you see a function that takes a non-const pointer, it's basically documentation saying, I am going to change your object. So if you care for it, take a copy of it first, because I am probably going to change your object. And this is something that, some kind of communication that you get if you are consistent about it. If you're not consistent about it, and it's like, I don't care, char instead of const char, whatever, then you are basically removing that way of communicating. So people would have to look in the documentation and maybe read your code to figure out whether it's going to change it or not. Let's now try to be inspired once again. And instead of just returning void, let's return the pointer that we get with intention, so that you can put it into these kind of sequences, or some people call them train wrecks. It is tempting to do that. It's fun to try to make C look like kind of those languages that can build up kind of pipelines and large train wrecks going on. But my experience is that it just works for a very narrow situation, and you probably don't want to go down that road with C. C is not it's not inviting to these kind of clever things. But while we are in this train wreck anyway, why not do something really ugly so that we get a chance to talk about it? This one, ugly. There is, I didn't change anything else here, I just changed inside here. You can see the difference between that one and just inside the remove dots. I just did this one, it's doing exactly the same just to prove that it's still printing hello. What I've done here, and yeah, the talk is about silly ways of saying hello, so therefore I allow myself to do this. And what I want to talk about here is this comma operator. The comma operator is not very often used. Well, it's sometimes in for loops it's used, but it's not very often used. But you sometimes find code bases where it is often used, and then it is nice to be able to read it and understand it. And the key point about comma operators is that they introduce sequence points. So at this point, there is a sequence point, and this expression is sequence before that one. So this is not undefined behavior. You can do several updates of the same objects through those, yeah, using the comma separator like this. Talking about sequence point, by the way, this one is also introducing a sequence point, and the shortcutting logical AND operator is introducing sequence points, so that's the reason why we can also read and update variables both before and after. Here I, just to be perhaps failed attempt to be funny, I did the same thing here. I'm actually null-terminating the thing here that nobody cares about. Then I use the comma operator, and then I actually return the value of q. So it's always the last element in the chain of comma operators there that is being returned as a result from this expression. Right, and then I'm still, I have to remind myself, I'm still just doing changes inside the remove dots here. This one, I think I would pass on the code review. It's idiomatic, it's okay. This is how C code is often written. This is the type of code you find if you read Koenig and Ritchie, for example, and a lot of other. Well, actually, there isn't any other good books about C. Well, there is one, and it came last year. And that's the book I gave out to my students. I was teaching C earlier this week. The new book by Robert Secord is actually really good. So finally, after how many years, I don't know. But this Effective C by Robert Secord, I can recommend it. I've read it very, very carefully. And it is actually a good book. So now we have two good books about C. Right, so this one is, well, yeah, this is something to mention here. Yeah, there's a small trick. When we are doing assignment in the expression used to find the condition of the while loop, it's often nice to put these braces around. Compilers are now often encouraging you to do so. It kind of communicates that, yeah, I know it's a single, that is an assignment operator that is inside instead of compare some operator. So it's a nice way of communicating. Sometimes I see this style where you put kind of 42 equal A and so on. Kind of Yoda style of writing conditions. I don't like that. You have other problems then if that's what you feel is a good idea. So this one is also giving hello. Oh, by the way, one thing. even in C, I try to, in C++, I always teach don't do multiple declarations on the same line. I try to do that in C as well, so I would normally not recommend this way of writing it, but at the same time it is so common and it's kind of part of the C tradition, so yeah, maybe not. Right, something completely different here. Notice that I've swapped two characters in the string now, and I need to unswap them, and therefore that gives me a chance to write a myswap function that takes pointers to two elements, two characters, and use this traditional swapping thingy. And this is kind of idiomatic way of doing it in C. And here is a nice way of taking the address of a particular element. You can do this in many other ways. You can say a plus 0 and a plus 2, for example. That will give you the same thing. I kind of feel this is slightly better because it's communicating that you're taking the address of that particular element. And but at the same time, it is very common to do it the other way as well. Hello. One more. Here I have written a my char comp that takes two void pointers, then cast them into const char pointers, and use that in an expression that is being returned, and this is exactly the kind of function that qsort wants. So in this case, I had messed up this string beyond, I wouldn't be able to figure out how I could sort it out myself with swap. So therefore I use qsort to do it. And notice that I'm here giving the base of this one, and I'm giving the string length -1 so that it doesn't sort a new line for me. I say that every element that it's sorting, because qsort is very agnostic in the types, so you have to basically say how big is the type. Maybe I should have used the size of an element there instead of writing one. Bad me. And then here we are giving the address to a function for qsort to use to compare every element that it's finding. And woohoo, it works! Yeah. Here I have, because in C11, before C11, you couldn't do concurrency or multi-threading in C, kind of pure C. You could ask the runtime, you could import something from the operating system and do threading, but you couldn't do portable threading in C. But after C11, you can. And what I'm trying to illustrate here is basically kind of typewriter thingy, so that the output from this one, it delays randomly, so that it looks like a typewriter when it writes out. So it looks like this. Yeah, or something like that. I was actually simulating it, but it works. Now to something completely different. I had actually planned to end the talk here and ask, can you turn off the camera, the video recording and so on? But then I decided, no, okay, it can be on video as well. Because I am trying to repair the reputation I have of always presenting undefined behavior kind of thing and having fun with that. But I couldn't resist. But first I'm going to show something that isn't undefined behavior, and which is part of the intention of C. The spirit of C is to, and the main inspiration for C came from BCPL and Martin Richards. Martin Richards had this philosophy of BCPL that I want to create a language that is easy to compile, that assume that programmers are clever people, a language that allows them to do whatever they want, and that the compiler should just be like a servant, obeying the programmer, even when confronted with apparent nonsense. And this is apparent nonsense, maybe, but it's perfectly okay. And in this case, I have decided, and the result might be slightly different from different machines as well, but on my machine, it prints hello. All right, so that is, of course, this can be undefined behavior on certain environments and so on, but it's within acceptable use of the language in my book. But now we come to a really cool one. Oh, I'm not sure if I want to show it to you. All right, I'm doing that anyway. I give you time to read it and reflect on things and think about your life as a programmer, and just give ourselves 30 seconds of silence while we are reading this. 30 seconds is long. All right, yeah, 15 seconds should do. What I've been doing here is that I've declared that there is a bool, but I haven't given it a value. Well, that wouldn't actually matter if I did or not. And then I create a char pointer, unsigned char pointer, and I say to the compiler, I know what I'm doing. Trust me. Trust me, I'm a programmer. What could possibly go wrong? So I take a pointer to the address of B, and then I dereference that pointer and put it to 42. Then I check. If B is true, I print he, and if it's not true, then I print lo. Now, what do we think might happen here? First of all, this is undefined. This is kind of beyond typical example of undefined behavior. But something happens on different machines and different compilers. And I just checked it before the talk, and I could confirm what I both hoped and I kind of knew what was going to happen, because the Clang compiler, without optimization, all of this is without optimization, the Clang compiler says low. The Intel compiler says hey. Would anyone like to guess what GCC says on this code? Of course. Thank you very much. That was the end of my talk.